Two things are constant in each scenario. The outside air temperature is 60 degrees, and the exhaust fan moves 30,000 cubic feet per minute of cold or hot air. 60 degrees at the fan, 30,000 CFM at the fan pulls 30,000 CFM through the front of the dryer. For every 3 balloons at the fan, 3 balloons are pulled through the front of the dryer. The front of the drum roars like a freight train. 350 degrees at the fan, 30,000 CFM at the fan pulls only 20,000 CFM. For every 3 balloons at the fan, 2 balloons are pulled through the front of the dryer. When the balloon is heated from 60 degrees to 350 degrees, the balloon expands to half again its size. This is enough air to heat and dry the 150 tons per hour the manager was expecting to dry. 600 degrees at the fan. 30,000 CFM at the fan pulls only 15,000 CFM. For every 3 balloons at the fan, 1.5 balloons are pulled through the front of the dryer. When the balloon is heated from 60 degrees to 600 degrees, the balloon expands to twice its size. This is enough air to heat and dry only 115 tons per hour, not the 150 tons per hour that the manager was expecting to dry. Although 600 degrees stack temperature is very extreme and hopefully rare, especially with a baghouse, these numbers were used to easily illustrate not only how hotter than necessary exhaust gases at the fan lowers production capacity, but also increases the energy costs. When the temperature changes through the fan, so does the amount of air being pulled through the front of the dryer. Air is necessary for combustion. When the exhaust fan pulls less air through the front of the dryer, the maximum burner output decreases as well. When this happens, the management should be disappointed. The temperature needs to be turned down by veiling aggregate through the dryer correctly. The payback is not only in production, but in saving energy. That extra heat being put in the atmosphere is now being put in the aggregate, allowing us to turn down the burner. A counterflow dryer should have no more than 220 to 230 degrees at the stack. If the temperature is higher than that, the temperature must be controlled downward. The temperature of a parallel flow should be about 10 to 20 degrees above the mixed temperature. Pressure drop troubleshooting. Use of manometer to take readings from the following 5 points. On a good production day, record these readings and calculate the pressure drops between points. On subsequent days, comparisons between readings can be analyzed and recorded. This is good information to have when things go wrong. Notice the baseline on the right is straight. When pressure drops deviate from the recorded good pressure drops, the baseline is not straight anymore. This makes a graphical picture of what the problem may be.